What are your axioms? We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So I got to thinking a little bit. Thinking can be dangerous because one might start asking questions. Questions can lead to solutions. I'm just saying there seems to be a lot of confusion about different stuff and things going on here within our realm of persistence. And there are folks that have answers. A lot of answers. Are they right? I guess we're going to have to see. But something about when Professor Wolfram was saying he was doing a deep dive into the second law of thermodynamics got me to thinking. It's like a lot of our modern interpretations were set like a long time ago, at least like, I don't know, maybe 100 plus years or so ago. And I'm like, okay, now, was that what people said? Or was this an interpretation that worked? And maybe we should go back to some of the history and see, because we hear about the Copenhagen interpretation. Oh, there are many worlds. Is there objective collapse? There's all this different stuff. And I'm like, that's cool. I mean, if we went maybe like a little further back, and maybe that would help us. I'm going to play this clip real quick about Professor Wolfram.
I have to say, somebody's mentioning dark matter, dark energy. I've been studying, I think I've said this too many times, I've been studying the second law of thermodynamics, law of entropy increase, for the last several months, actually, because I've realized that some things we've done in our physics project kind of open up a bunch of things that people have been confused about, including myself. I've been confused about these things for 50 years. The world in general has been confused about them for 150 years. So, but in any case, one of the things that I'm really struck by in the early days of the development of ideas about thermodynamics, there was this idea of the caloric theory of heat, where the idea was that heat is a fluid that kind of suffuses all substances. And that's what heat is. As we know now, heat is, the motion of molecules and so on. But I just have this tremendous image of dark matter is the caloric fluid of modern times, that it's not what you think it is. It's not something which is described, at the time when people were talking about caloric fluid, people knew there was air as sort of a fluid and there was water as a fluid, and fluids were a thing that was a sort of a description for how things work in the world. They didn't think of the idea, or some people did, but mostly they didn't think of the idea, it's motion of molecules. And I think the same is happening probably with dark matter and so on. The people say, well, it's, what we know about is particles. It must just be other particles. But it's actually probably something that takes a bit more creativity and imagination to realize. And our physics project should be able to tell one what kinds of things might be out there that are not what you thought were there.
I'm just saying, when you start looking into some of these things, it gets really fascinating. All right, we go to Eric Dullard, who we mentioned the other day. So this is on the origins of energy synthesis. Take it away, sir. I'm also not sure when this video is from. I think this may be from like 15 or 20 years ago. I'm just judging by some of the quality and some of the references.
Interpretation of J.J. Thomson's discovery of the electron greatly hampered the understanding of electricity. And in 1900, Steinmetz summarizes the situation in one of his books. He says, unfortunately, to a large extent in dealing with the dielectric field, the prehistoric conception of the electrostatic charge on the conductor still exists, and thereby its use destroys the analogy between the two components of the electric field, the magnetic and the dielectric, and make the consideration of the dielectric field unnecessary complicated. In actuality, it eliminates the dielectric field and makes it so that you can't calculate it, and substitutes electron flow in its place. Wires are not conductors of electricity. This misconception of so-called conductors or wires carrying electricity like water in a pipe was continuously attacked by Heaviside in his writings. The entire article is written on the matter titled A Perfect Conductor is a perfect obstructor, but does not absorb the electromagnetic energy of the waves. Heaviside states, it was discovered by mathematical reasoning that when an electric current is started in a wire, it begins entirely at its skin, in fact, upon the outside of the skin, and that, in consequence, sufficiently rapidly impressed fluctuations of the current keep to the skin of the wire and do not sensibly penetrate its interior.
So here's my thing with this. A lot of people really kind of got into that Veritasium video where he's like, how long will it take for, like, if I flip this switch, how long will it take for this light bulb to go on? It's like 1 over C or something. It's something like that. I or C over whatever it was. Basically, is it going to work at essentially the speed of light, or are we going to have to do some calculation here? And he was supposed to be for, like, around the Earth, hypothetically, and everything. And apparently, the answer, the whole point of the video was, a lot of it, me included, were like, how does electricity work? You can get a bunch of wires and stuff. You got electrons and stuff. They're electrical. That makes sense. But basically, this kind of proved that it's like, oh, it's actually the field. The field specifically seems to be strongest around it, not in the center. Seems kind of weird. I'm just saying that what are we actually talking about here? Okay, so thank you, Mr. Dollard. We're gonna go back to some of the references that he made here. Okay, go to our window. Boom. Okay. So at one point he gets into Sir Edmund Taylor Whittaker and some of the contributions. We're Trinity College, Cambridge. A lot of philosophy, did a lot of stuff. Took on the role as the Royal Astronomer of Ireland. Oh, he was head of mathematics. Where was the work here? Some life, legacy. Okay. In addition to his textbooks and works, several of which remain in print, Whittaker is remembered for his research in automorphic functions. A mathematical automorphic function is a function on a space that is invariant under the action of some group. In other words, a function to the quotient space. Quotient, that's the vision. Often, the space is a complex manifold, and the group is a discrete group. Talking about some complexity. Oh, numerical analysis, harmonic analysis, and general relativity. Well, that's pretty neat. Where is it? Harmonic functions. We were talking about some harmonics the other day. Okay. Oh, and a course for modern analysis, analytical dynamics of particles and rigid bodies. What else would? A history of the theories of ether and electricity. Oh, that ether that totally doesn't exist again. Or at least according to an experiment from like 100 years ago. I'm just saying we didn't have iPhones back then. Does that affect whether there's ether or not? No idea. But we go to Steinmetz. Charles Proteus Steinmetz. All right. What was some of the work? Oh, he was an electrical engineer as well. Oh. His contributions to 3 major fields of alternating current, hysteresis. Magnetic hysteresis occurs when an external magnetic field is applied to a ferromagnet, such as iron, and atomic dipoles align themselves with it. Even when the field is removed, part of the alignment will be retained. Is that entanglement? No idea. Hey, Rob. Welcome, my friend. Thank you for joining us. And steady state analysis. Oh. Well, a lot of folks aren't always fans of that, but transient response, electrical engineering and mechanical engineering. A transient response is a response of a system to a change from an equilibrium or steady state. The transient response is not necessarily a time to abrupt events, but to any event that affects the equilibrium. Oh, well, that's hidden variables or something. I don't know. It popped up Professor Carroll's, one of his AMAs. People were asking about it. It's like, well, okay. Hey, Kodov. Oh, welcome, my friend. Be wary. The means of destruction channel does not promote entheogen use unless it's properly prescribed by a physician. and obviously distributed by a multi-billion-dollar pharmaceutical company. The opinions on the memes of the structured channel are mine alone. But be wary about frying your brain, I'm just saying. Yeah. We go to Oliver Heaviside. Oh my God, look at that haircut. I kind of want to do that. I think my hair is long enough. It looks like Wolverine. But, oh God. Was an English self-taught mathematician and physicist who invented a new technique for solving differential equations, equivalent to the Laplace transform. I hear a lot of different physics folks mentioning that as well. Yes, electricity history is just shocking. That's totally. Well, is there one axiom? I don't know. According to the girls' theorem, we're always going to have an assumption. We always need to have at least one within whatever rule set that we actually believe are true. But it's very interesting. Professor Wolfram also brought that up. What is it? He inevitably developed the vector calculus and rewrote Maxwell's equations in the form commonly used today. He significantly shaped the way Maxwell equations are understood and applied in the decades following Maxwell's death. His formulation of telegrapher's equations, which is a pair of coupled linear partial differential equations that describe voltage and current on an electrical transmission line with distance and time. The question, is that the D over T thing or whatever? Or can we use it? Became commercially important during his own lifetime, and their significance went unremarked for and after their significance went unremarked for a long while, and a few others versed the same time as nodal methodology, at odds with the scientific establishment for most of his life. Heaviside changed the face of telecommunications, mathematics, and science. Wait a second. Some people might have some ideas that other people disagree with. Imagine my shock. Pun intended. But you can look it up too. It's okay. It's okay. This isn't a completely deep dive stream. That's from Camden, London. But as we scroll down here, we're talking about things being a perfect conductor is a perfect obstructor. What might that be in regards to? I studied things with the possibility of gravitational waves was also discussed by Heaviside using the analogy between the inverse square law and gravitational electricity. That's some forward thinking. With quaternion multiplication, the square of a vector is a negative quantity. That's why I is important, I guess. Much to Heaviside's displeasure. Oh, he looked at something he didn't want to be true. He's like, you know what? If this is what it is, this is what it is. He has been credited by C.J. Jolly with developing hyperbolic quaternions. Abstract algebra. The algebra of hyperbolic quaternions is a non-associative algebra over the real numbers with elements in the form of Q equals A plus BI plus CJ plus DK. Oh, it's like a little rhyme. The Heaviside step function, the current, the delta. He was the first to use the unit impulse function, now usually known as the Dirac delta function. He invented his operational calculus method for solving differential. Okay, where was it? It was in 1880, Heaviside researched the skin effect in telegraph transmission lines. What is a skin effect? Oh, look at that. Skin effect is the tendency of an alternating electric current to become distributed within a conductor such that the current density is largest near the surface of the conductor and decreases exponentially with greater depths in the conductor. Electric current flows mainly at the skin of the conductor between the outer surface and a level called the skin depth. The skin depth depends on the frequency of the alternating current. As frequency increases, current flow moves to the surface, resulting in less skin depth. Skin effect reduces the effective cross-section of the conductor and thus increases its effective resistance. Skin effect is caused by opposing eddy currents. Eddies, you say? Oh, it's kind of like a little twirl, kind of a vortex, if you would. Induced by the changing magnetic field resulting from the alternating current at 60 hertz. In copper, the skin depth is about 8.5 millimeters. Is that why we use a lot of 8.5 millimeters? I don't know. At high frequencies, the skin depth becomes much smaller. Okay. Now, again, I'm just conjecturing here that might some of the things, I don't know, maybe some of the vacuum energy or whatnot, let's say there's some form of a medium. I hear folks say superfluid. That's kind of cool. It's totally not the ether. We know that because reasons. I'm just saying that, I don't know, if we go back to maybe 100, 150 years or so, maybe a few hundred, and look at how we developed a lot of the things we're using, might there be some interpretations that we've overlooked? Maybe they're too hard back then, and we found things. It's like, oh my god, it's like the laws of Newton that did really dang well, and it's like, okay, yeah, Mercury, okay, we're not quite there. Oh, GR, beautiful, beautiful. GR's carried us so far. What happens if we get to another point? It's like, what if there's something that, like, I don't know. It's something that somebody said 150 years ago. It's like, if we apply it now, do we have the technology? Do we have the computational power and everything? But hey, the axiom of surface Monterey, that's a pretty important one. Just got to remember, everyone loves to buy. Nobody likes to be sold. That's the thing, just have the discussion. It's like, if you disagree, just explain why you disagree. Remember, if you're going to have some discourse, attack the argument, not the person. Otherwise, that's an ad hominem attack, and then people start throwing mud, yada, 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 and it makes me want to have to legalize dueling. I'd rather not do that. I'm just saying, we got a lot of smart folks out there. I've spoken to a lot of them, and some of these folks aren't always in the public limelight. I'm just saying, occasionally out there, there might be some ideas that could really help us move forward. It would be a shame if we overlook them. But yeah, that's all I got for now. Hey, thank you all for joining. Be safe. Merry Christmas. Happy Hanukkah. Happy Kwanzaa. Happy Festivus. Happy holidays. Have a happy new year, everyone. And we're out. Peace out, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.